This is problem 8, exercise 8 on chapter 2. I've had a couple of requests to make a video for how to work this one. And I think what may be confusing a couple of people is that the book actually provided a table here in gray and suggested that you change the annual payment using GoalSeek to arrive at the correct answer. And so the way the problem is set up, the book gives you this table. They have a placeholder or a guess in here for an annual savings of $10,000 each year for 10 years while the person is working. And then after retirement, the person withdraws $100,000 per year for a lifespan of 84 years. And so the book intention is for you to goal seek such that the ending balance, and we'll say data what if analysis goal seek, and set that ending balance to 0 by changing that assumed $10,000 annual deposit while she's working. And if we do that, we get an answer of $37,411 deposited over 10 years each year. And then the withdrawals of $100,000 cause her to run out of money right at the end of her expected lifespan, morbid as that may be. So the way I set up the problem the first time was I set up a future value problem to see how much money she would have after 10 working years. And let's come over here to a place where we can save this. So for 10 working years, beginning with $500,000, and for each of 10 years, depositing $10,000 as the book recommends as a placeholder, growing at 5%, we can calculate the number of dollars that she would have at the end of her working years. And I think when we did this example in class, the example I used was when she's eating her retirement cake, what is the future value of her account at that time? And I believe all of these went in at the beginning of the period, so we'll use a type equal to 1. And at $10,000 savings, she'd have an account balance available for withdrawal of $946,000. So if we take that as the starting point in retirement, and here's where those signs can kind of get persnickety. Take that as our present value on the day she eats her cake, and then she needs 20 years with a 5% growth rate and $100,000 per year withdrawal. We can find out what she'll have at the end of this approximated lifespan. So again, we'll use the future value formula. It's critical here that the payment and the present value have opposite signs and that the type is 1. As we discussed in class yesterday, these withdrawals really need to be at the beginning of the year because when she retires, she'll need that money right away. And when she dies, she won't need that last deposit if she takes it out on the day she dies. And at this assumed $10,000, then she doesn't have a 0 balance at the end of her lifespan. She has, I think it's actually a negative $960,000. So let's goal seek that value to 0 by changing that annual deposit that she makes while working. And we should get the same $37,411. Now, after looking at this problem today, I think a much simpler way to approach the problem would be to say, how much does she need to begin retirement? That would be a present value on the day that she's eating her cake. And what she would need is 20 years with a growth rate of 5% and an annual withdrawal of $100,000 per year. And she wants to run out of money. We don't need to use the 0, but I will for clarity. She wants to run out of money at the end of the 20 years. And so the present value would simply be the rate over 20 years of withdrawals of $100,000 per year. And we can use the 0 or not, but it needs to be at the beginning of the period. And so this tells us that she needs $1.3 million when she's eating that retirement cake. And so some of these are inputs. And the amount that she needs for retirement is what we calculated as an output. So if we think that that's what she needs when she eats the retirement cake, present value on that day, it's really the future value from today's perspective. So I'm going to make it negative and try to outsmart Excel on some of these signs. I don't know if that's necessary. But we know that she's going to have 10 years to save for retirement, and that the earnings rate during those 10 years is 5%. And that she's actually going to start out today with a present value of $500,000. So all we need to do is calculate the payment, the deposit that she needs to make. And so if we say PMT at 5% over 10 years with a present value, to gain that future value with payments at the beginning of the year, we get the same $37,411. We didn't have to use goal seek.